So hi everyone, welcome to your channel Impulse Tech. I am Yogesh Bhavne. So today I come up with a very interesting video which is based upon the ESP-NOW protocol. So now here in this video we are going to send data from ESP32 board to one ESP8266 board, that is Node MCU. So we are going to send data wirelessly from ESP32 to the ESP8266 by using ESP-NOW protocol. Now let's just explore what is ESP-NOW protocol. So now this protocol is developed by Espressif system. As you know that the ESP32 ESP8266, that is Node MCU, which is manufactured by the Espressif system. Now this protocol used to transmit the short packet data wirelessly between the many ESP32 board, or you can say between the ESP8266 board or between the ESP32 board. It can be mixture of both ESP32 as well as the ESP8266, that is Node MCU. So it doesn't require any Wi-Fi or the router network to transfer the data between the boards. So how does this possible? So this is what we are going to learn today. Now as you can see, I have two boards here. One is ESP32 and one is ESP8266. Now connection is peer-to-peer with no handshake is being required. Now what does it mean? Let's see. So now I have here one ESP32 and one ESP8266, that is Node MCU. So I am transferring the data from ESP32 to Node MCU wirelessly by using ESP-NOW protocol. Now for example, consider this board's power supply cut off. Now this board doesn't receive any data. So if we turn on this board after some time, then you don't need to pair it, or you don't need to upload code once again. It will automatically get paired once it gets powered up. So that's why they are saying like it will peer-to-peer connection and with no handshake is being required. That means, so whenever this board got turned on, it will automatically connect to another board, that is Node MCU, and automatically start sharing the data. So that's why they are saying with no handshake is being required. Now this protocol can work with both the boards, that is ESP32 and the ESP8266. So we can use this protocol for transferring the data from ESP32 to the many ESP32 board, or you can transfer the data from one ESP32 board to the ESP8266 board as well. So this can be a mix match combination. So now this protocol has the range up to 480 meters. Now I have given the question mark. Now we need to test this range, that we are getting this much range or not. So I will test this range in the outside premises. So now there is one limitation for this protocol, that you can only able to transfer small messages up to 250 bytes. But this can be good for transferring the sensor data or transferring the button state like on and off. Yes, we can easily do that. So we are going to see that in our video. So now let's see what are the different types of communication provided by the ESP-NOW. So the first one is one-way communication. Now what does it mean? Let's just understand with one example. For example, I am a speaker, I am teaching something on the board and there are 100 students. So I am the only one who is teaching. There is no response from the student side. There is no communication from the student side. I am the only one who is speaking out. So that means there is only one-way communication. I am the only one who is speaking. So now here in case of ESP-NOW protocol, the same thing. Like one ESP32 board can transfer the data or message to another ESP32 board. So this is the one-way communication. So one act as a master and other act as a slave. That means one act as a sender and one act as a receiver. So this is also the case in the one-way communication. Like as I said the example, like there are 100 students and I am the only one who is speaking. Here you can see, here is the only one student, that is ESP32 sending data to another ESP32. Only one-way communication with one student you can consider. Like here you can consider one act as a master and there are many ESP32 boards receiving the data from the master. The boards which are receiving data from the master act as a slave, or you can say they are act as a receiver. So they are receiving the data. So they are only receiving the data from the master. So this is the case in the one-way communication. So that's why we are calling it one-way communication. Receiver does not sending the data to the master. Only master is sending the data to the receiver. So we have seen two cases. One is ESP32, only single ESP32 sending data to the single ESP32, that is master to slave. Now the second case we have seen that one master sending data to the multiple slaves. So the third case is exactly opposite of the second case. That is single slave receiving the data from the multiple masters. You can understand it with an first example, that is here teacher is receiving the questions from the student side. Only teacher is listening now, you can consider. So there are three cases in one-way communication. First is one ESP32 board sending data to the another ESP32 board, that is one-way communication only, so master to slave. Now this is the second case where one ESP32 board sending data to multiple slaves, and the third one is one slave receiving the data from multiple masters. So this is the cases inside the one-way communication. Now let's just see two-way communication now. So in two-way communication, both the boards send and receive the data in between them. Here you can see. Now this is the case inside the two-way communication. Any board can act as a master or any board can act as a slave. Here you can see multiple boards can share the data in between them. So this is about the two-way communication. What are the different applications of this protocol? So we can use this ESP-NOW protocol for remote sensor data monitoring. If you have seen in real life industries, we need to monitor the sensors data. We need to monitor the sensors data at far locations. So what we can do, we can place one ESP32 board as a master and another ESP32 board or the ESP8266 board as a receiver. So we can transfer the data between them and receive the sensor data in one control room. So this is how we can use it as a remote sensor data monitoring. Now it can be used as IoT applications. Now in my next video, I am going to build an IoT project which is like, so we are collecting sensor data at one ESP32 board and sending that data to another slave, that is ESP8266, and after that we are transferring that data to the IoT cloud. So this is how we can able to build the IoT application by using this protocol as well. So you can use this as a remote control as well. So we are going to build the home automation project by using this protocol as well without using the internet or anything. So in order to send the data from one master to the multiple ESP8266 or multiple ESP32 board, we are going to use the MAC addresses of the slave boards. Now how will you get the MAC address? So let's see how to find the MAC addresses of the receiver boards. Now this is the simple basic line of code which is used to find out the MAC addresses of the board. Now in ESP-NOW protocol, we need to find out the MAC addresses in order to connect the board to each other. So every board has a unique MAC address. So in this video, I am going to send the analog data from ESP32 board to the ESP8266 board. So my ESP32 board acts as a master and ESP8266 board, that is Node MCU, act as a receiver, or you can say slave. So I need to find out the MAC address for Node MCU. So I will connect my Node MCU and I will upload this code and we will find out the MAC address, and then we will use this MAC address in the ESP32 programming. Let's just see. So as you can see on the screen, the code is uploading. So code is successfully uploaded. Now click on the serial monitor. So here you need to press the boot button because the code is inside the white setup, which will run only once. So let's just click on reset button. I'll just click on reset button and let's see. So here you can see the MAC address. So let's just copy this MAC address and just store somewhere where you can able to access it. So I have copied this MAC address. So we have got the MAC address for the receiver board, that is Node MCU. So we are going to use this MAC address in the receiver side of programming. So now we have just seen that we have got the MAC address for the receiver board, that is for the ESP8266 board. So now we are going to use this MAC address inside the programming. Let's see. So this is the code for the sender side. So sender side, we are using the ESP32 board, as I have already told you, with the potentiometer. As you can see, the output of the potentiometer is connected to the pin number 34 of the ESP32 board. It's very simple. Now from where you will get this code? You will get the code for master and slave. Just go to the file, go to the examples and go to the ESP32 board, and here you can see the ESP-NOW. Click on basic and click on master. So if you click on master, you will get the code for master, that is for sender, right? So this is the code for sending the data from the master. So if you wanted to get the code for slave, that is for receiver, then go to the example once again, go to ESP32 board and go to ESP-NOW and click on basic and slave. So now this is the code for receiver side. So here we are demonstrating the one-way communication protocol, that is ESP32 board act as a sender and ESP8266, which is Node MCU, act as a receiver. Now, so this is the programming for sender, that is master. So now here we have included two libraries, that is espnow.h and wifi.h. So if you select the board ESP32, then you don't need to download this library or you need to install, just include it inside the code. Now here I have declared one pin which is pot pin, that is potentiometer is connected to the pin number 34 of the ESP32 board. Now here you need to enter the MAC address of receiver board, that is slave board, that we have found out. So here this is my receiver board with the OLED. So this is the ESP8266 board. So we need to enter the MAC address for the receiver board. So here you can see I have entered the MAC address for the same. So you need to enter the MAC address in this manner only. Like you are going to get the MAC address like 60.01.94.29.8D. So before that you need to enter this 0x. Okay. So now if you have more than one receiver devices, then you can enter the MAC address for the same like this. So just remove this comment line and enter the MAC address for the second receiver board or second slave board. So here I am only using one receiver board, so that's why I have entered only one MAC address. So here we have created the structure called state structure. Now what is structure? So I will explain you with a simple example. Now we know that variable can able to store the data, right? So we can consider variable is like a simple box which can able to store the only same kind of thing. Like for example, if I consider this box, so this box can able to store, let's say, screws. So this we will give the name to this box as a screw. It means this box contains only screw. So same box contains screw, screwdriver or the insulation tape. Then this kind of thing is known as the structure. What does it mean? Like, so inside the structure we can able to hold the different kinds of data type. Like we can able to store integer, character or float. So here you can see inside the structure I have defined only one variable, that is pod data. So pod data is the variable which is used to store the potentiometer data. So also we have declared one variable for the structure, that is test. So this variable is storing the data inside the structure. Again there is one variable, that is ESP-NOW peer info. So this variable is used to store the information related to the peer. Peer means your receiver board. So now here you can see there is one function, that is on data sent. So this function will get executed whenever your sender board sends the data to the receiver board. So it will tell you whether the delivery is. So this function get executed whenever we send data from the sender to the receiver. So if the data is get successfully delivered, then it will print on the serial monitor, that is delivery success. And if the data is doesn't received by the receiver board, then it will print on this serial monitor, that is delivery fail. So we will use this function whenever the data is sent to the peer, that is receiver board. So inside the white setup we have initialized few things. First we have initialized the serial monitor in order to print the data on the serial monitor, and also we have set our sender in the station mode. Here you can see, and also we need to initialize the ESP-NOW protocol. Here you can see. After that we need to register the receiver device in order to send the data. So this is the code which is useful for registering the peer. Peer means your receiver device. So here I have just used only one receiver, so that's why I added the only this line of code. So if you wanted to add 2-3 receivers, then you need to copy these lines of code and just enter it. Now let's see what we have done inside the while loop. Now here you can see inside the while loop we are accessing the data from the structure. So test is a structure that we have created, as I've already told you. Inside the structure we are having the data. So here you can see I have created one variable inside the structure, that is pod data. So now we need to access that variable. So in order to access that variable, what you need to do, you need to type test.poddata. For example, if here we are having one more variable, I'll write here float, and I'll write here something like called, like for example, let's consider sensor and semicolon. So for example, if this is another variable inside the structure, then how you are going to access it inside the void loop? Let's see. So you are going to access it like by using this kind of command, like test, this is the structure name, dot, and the variable that you have created, which is sensor. So this is how you are going to access the data from the structure. So name of the structure dot the name of the variable that you have created inside the structure. If you are not understanding anything, just let me know inside the comment section. So here I am just sending the potentiometer data. So instead of sending the potentiometer data, what you can do, you can send the data of temperature and humidity, right? So you need to create a structure for that. Like, so inside the structure you need to add temperature and humidity variables. So now I wanted to store the potentiometer data inside the pod data, right? So what I'm doing, I'm just using this command, that is analog read pod pin. So pod pin is nothing but it's a pin number 34. So, and if you wanted to print this data on the serial monitor, then you can do that as well. Serial.println test.pod data. So now, in order to send the data to the peer or receiver, we are using this ESP-NOW send function, and we are passing the argument that is 0. So we are passing the argument 0. That means we wanted to send the same data to all the receiver, and this line of code is useful for to detect that we are able to send the data or not. So this is about the sender side of programming. Now we will see what are the changes we need to do inside the receiver side of programming. So in the receiver side of programming, what I have done, I have connected one OLED display. If you are able to see, here you can see I have connected one OLED display. So I will show you the circuit diagram as well. So this is the simple circuit diagram in order to connect OLED display to the ESP8266 board. So here you can see HCL is connected to the pin number D1, SDA is connected to the pin number D2, and the VDD, which is VCC, is connected to the 3V3, and ground is connected to the ground of the ESP8266 board. So this is the simple connection for the OLED display with the ESP8266. Now we'll see the code. What are the changes that we need to do? Same thing that we need to do, that we need to include few libraries. So here we are using the OLED display with the receiver board. So that's why we need to include the libraries for the OLED display as well. So I will add the list of the libraries that you will need to install for the OLED display. Here you can see we have created the structure here as well. So the same structure that we have created inside the sender side, the same structure that you need to create inside the receiver side as well. So here we can see must match the sender structure. Here we have created another variable. Here the variable that we have created is my data for this structure. So in the sender side we have created the test. So now here you can see on data receive. So on data receive is the callback function. It will get executed whenever you receive data from the sender via ESP-NOW protocol. So we are receiving the data from ESP32 board on the ESP8266. So this function gets called, and it has these parameters like incoming data, like length of the data, and the MAC address. So we wanted to copy this incoming data to the variable that we have created. So we have created the variable that is my data, and we wanted to copy the data that is incoming data to this variable, right? So that's why we are doing here copy kind of thing. Here we are copying the data that is incoming data to the variable that is my data. Now we wanted to print on the serial monitor what is the length of this data and the data that we are getting. So now in order to access the data that you are getting from the sender, so you need to use my data and the same thing that we have done inside the sender side, like we used to use the dot. So use my data dot pod data. So this is the variable, you know that, which is inside the structure. So access it like my data dot pod data. This is simple. So inside the void setup I have initialized the OLED display, and also I have initialized the ESP-NOW protocol. And inside the void loop, what I have done, I have just written the code for printing the values on the OLED display. So this is about the programming for the both the side, from the sender to receiver. I will upload this code to the each board and we'll see that whether we are getting the output or not. So let's see now. So first we will upload this receiver side of code. So let me select the board. So receiver side I am using the ESP8266 and select the board. Let's go to the ESP8266 and select node MCU 1.0 12V module, and then select the port. So port is selected, COM port 4. Now let's click on upload. So the code is successfully uploaded on the receiver end. So now I will upload the code for the sender end, that is for ESP32 board. So now let me go to the sender code. So this is our sender code. So let me select the board. So we need to select the ESP32 board. So let's select ESP32. So COM port is selected. Let's click on upload. So now code is uploading. Whenever it says connecting, you need to press the boot button. Let's press the boot button now. So the code is successfully uploaded. So now I just wanted to show you my setup on the screen. So first, so here on the screen you can see I have connected ESP32 board and uploaded the code, and this is our receiver board, that is ESP8266 with the OLED display. So now this board is sending the data, but this is not receiving the data because we have not connected it to the power. So now on the screen you can see on the serial monitor the delivery fail. You can see sent with success, but the delivery fail. It does not delivered, right? The data is not delivered. So what I'll do, I'll just power it up. Let's see. So we'll power the receiver side and we'll see that whether we are receiving the data or not. as soon as I powered the board, the data is received by the receiver, that is ESP8266 board, and they're displaying it on the OLED. So and the same thing, let's click on the serial monitor now and see. The serial monitor says that the delivery is success. So the sender is delivering the data and the receiver is receiving the data on the screen, you can see. So now what I'll do, I'll just try to rotate the knob of the potentiometer and let's just see that whether we're able to control the data. So we're able to get the variable data in real time. This is very fast, as you can see. This is very fast. So this is how we're sending the data from ESP32 board to the ESP8266 by using the ESP-NOW protocol. So now we will do one more project in the same thing. So I just wanted to control the LED from the sender board. So whenever I press the boot button, the LED on the receiver side should turn on. So let's see now. So this is the sender side code which is for ESP32 board. So let's see what are the changes that we need to do. So inside the structure, I have created one variable that is button state. So here we wanted to store the whether it's on or off. So inside the void loop, we are accessing that variable and we know that how to access it. So this is the structure that is test dot button state, and now here digital read 0 which is boot button. So this is the simple code which you need to modify in order to control the LED from the sender to the receiver end LED. And I just wanted to explain you the receiver code as well. So let's see what are the modifications that I've done inside the receiver code. So this is the receiver end code. So here you can see I have declared one variable that is LED is equal to D5. So you need to use one LED, just take one LED and connect it to the pin number D5. So I have used the pin number D5 here. And again we need to declare the structure which is similar to the structure which is present inside the sender code. So the same structure, that is button state, here you can see. Now let's go to the function on data receive. Here you can see, so whenever we receive the data from the sender, what we wanted to do. So we are sending the data that is button state and we wanted to control the LED from the receiver side. So that's why I am using digital write LED which is connected to the D5 with my data dot button state. You know that this my data is a structure and this is the button state variable that is inside the my data. So this button state variable storing the 0 or 1. So that's why we are digitally writing the LED with the my data dot button state. So it will turn on and off whenever it receives the data from sender. So this is the simple line of code that you need to modify in order to control the LED wirelessly. So in the next video I will show you the range of the ESP-NOW protocol. So I will upload the code. So now the code is uploaded for ESP32 board. Let's upload it for the receiver side, that is ESP8266 board. So as you can see on the screen, the green LED is turned on. So now I wanted to control this LED from this sender board. So just press the boot button and let's just see whether we are able to control it or not. So here you can see I can able to control it real time with very less delay. There is no delay, it's a real time controlling. Here you can see I'm just pressing the button on and off. So by using ESP-NOW protocol, we can able to control the devices as well. So in my upcoming video, I am going to build the home automation project by using the ESP-NOW protocol. So if you found this video helpful to you, then just do subscribe the channel and like the video. So thanks for watching. See you in the next video.